The purpose of this video is to show you how many-to-many relationships allow you to associate rows of data in a many-to-many relationship in the real life. I'm going to use Excel here, but you wouldn't do this design in Excel. I'm using Excel here like I would a whiteboard or in order to explain something to you, not as a way of actually designing a database. In this case, the many-to-many relationship is between an orders table right here and items in a products table. You have orders that have many different products on it and products that can be associated with many different orders. If you only have these two tables, orders table and products table, in the same database, then you won't know which products are associated with which orders and which orders have which products on them. So you need to have in the middle what's called a junction table, or an associative entity, or an association table, whatever you want to call it, that will marry these two tables together so you can tell you can retrieve which products were on which order. In this case, we have two orders, order 1 and order 2, and we have three products 8, 9, and 10, each with their own descriptions and other information. In this case, we know from the junction table, where all the action is that order 1 had 2 rows of data on it. You could also call this order detail table if you wanted, because it gives you the details of the particular order. But we know that order 1 had 2 products on it, order 8 and order 10. Product ID 8 and product ID 10. And if you go over here into the products table, you'll see that product ID 8 is associated with socks and product ID 9 describes shoes as well as their respective prices. We know that order 1 also has a certain order number that appears on the customer's invoice and also an order date. So with all this information in hand, we can reconstruct the invoice by doing a query on the database. We could say, I want to know what the order details and all for order number 1002. Your database management system would go into the orders table and would search for order 1002, and it would see, oh, okay, its primary key is a number 1. The database management system would then go looking in the order products table and see a row item which has an order ID of 1. It would say, well, the first row, the first product in this junction table is product number 8. So it would then be able to then associate the socks with this particular order, and that 5 of them were actually sold. We could do the same thing down here. It would say, here's another order ID of 1. It would go look into this table and see again, yes, that's order 1002 that I'm searching for, and that's the order date. And it could also see that the product on that order was product 10, which is hats. Also that we sold 2 of those hats. So with this information, all this in the table, users can run queries on the database to pull out the information they need for specific order numbers. And in this case, we could create an invoice for order number 1002. The database management system finds 1002, sees that it's order 1, and pulls off the date and puts it here. So 1002 and 110-2015 would be gathered from the lookup into the orders table. Then it would go into the order products table, find order ID 1, because that's the one we're interested in here. And it would say, okay, product ID is product 8. It would go in the products table, it would look up product 8, ID 8, and it would say, oh, these are socks, and it would put socks here. It would also notice that there were 5 units sold of product ID 8 on this particular order and put the 5 here. It could also then go into the products table, look up number 8 again for this product and see that the price was $2. It would then multiply these two when you run the query and indicate that the total was $10 for that line item. It would then notice that this order 1002, whose order ID is 1, has another row in the junction table, and it would say, oh, there's another product on this order, it's product number 10. It would then go into the products table, pull up 10, and see that they were hats. And would also notice that there were 2 of these hats sold, because that's the unit sold associated with order ID 1, product 10. So it would put a 2 in here because those are the number of hats sold. The database management system would multiply 2 by $10 and get $20, and then the database management system would add up, when you run the query, the total for that particular order. It could calculate taxes and a grand total, an even bigger total, other than this one if you wanted. So what makes this work is the junction table. And by combining the foreign keys of the order ID and the product ID, you end up with what's called a concatenated key or a composite key of the two of the order and the product combined, which in this case would be 18. The second row would have a unique identifier. Its primary key would be 110. And you'll note that any order, if I add a new order, order 3 into this table, and it has, just shoes on it, and we only bought one pair of shoes, it would have a primary key of 39. And you could look up all of the items on that order just the way we did with order ID 1. And that explains how many-to-many relationships look from a data perspective. And that might help you understand why we design tables in a many-to-many relationship when we're designing them in Microsoft Visio or some other database modeling software.